For over 100 years, the flying car has been one of humanity's most persistent dreams and one of its most consistent failures. Every decade, a new design, a new prototype, a new round of press coverage, a new promise that personal aviation was finally arriving for ordinary people. And then silence. The vehicle would disappear into a hangar. The company would run out of money. The regulatory challenge would prove insurmountable. The engineering wouldn't quite work. This cycle repeated itself with remarkable consistency from 1917, when Glenn Curtiss built his autoplane that barely left the ground through the 1940s, the 1960s, the 1990s, and into the 2000s. The flying car was always 5 years away, until now. Right now, in 2025 and 2026, something completely different is happening. 3 real personal flying vehicles are on the market, not concepts living inside PowerPoint presentations, not prototypes gathering dust in a hangar, waiting for more funding. Not press releases about vehicles that will be available soon. The Helix by Pivotal began customer shipments on June 10, 2024, the world's first commercial eVTOL to begin scaled production deliveries. Klein Vision unveiled its production prototype at the 2025 Living Legends of Aviation Gala Dinner in Beverly Hills, California. 35 years of development across 5 generations of prototypes, culminating in a vehicle ready for commercial sale in early 2026. Alef Aeronautics announced its Model A had received special airworthiness certification from the Federal Aviation Administration, the first flying car to receive U.S. government approval for flight that is also drivable on public roads. 3 vehicles on sale with price tags, with delivery schedules, with real customers already flying. And the global industry surrounding them is growing at a pace that would have seemed impossible just 5 years ago. The global eVTOL aircraft market size was estimated at $1.35 billion in 2023 and is projected to reach $28.6 billion by 2030, growing at a CAGR of 54.9% from 2024 to 2030. 54.9% compound annual growth rate. That is one of the fastest growing industries in the entire global economy. Today, I am taking you inside all 3 of these vehicles, everything you need to know about each one, what they are, how they work, what they cost, what they can and cannot do, and what these 3 very different approaches tell us about where personal aviation is genuinely heading. This is not science fiction anymore. Stay with me. The industry context. Why this moment is different. Before we go into the individual vehicles, you need to understand why these 3 are succeeding right now when everything before them failed. Because the timing is not accidental. 3 specific technological shifts happened in the last decade that changed the fundamental economics and engineering of personal aviation. First, battery technology. The energy density of lithium-ion batteries has improved dramatically over the past 15 years, driven primarily by the electric vehicle revolution. Better batteries mean more energy and less weight. And weight is everything in aviation. As batteries become more powerful, lighter, and capable of faster charging times, eVTOLs can fly longer distances with shorter downtimes, making them more practical and appealing for urban air mobility and other applications. Second, electric motors. An electric motor is fundamentally different from a combustion engine in ways that matter enormously for personal aviation. It is small, lightweight, produces instant torque, and can be produced in miniaturized form at low cost. Multiple small motors can be distributed across an aircraft, each one independently controlled, creating a redundancy that was impossible with heavy, complex combustion engines. If one motor fails, the aircraft software compensates automatically using the remaining motors. The vehicle doesn't fall out of the sky. This distributed electric propulsion principle is the core safety architecture behind every one of the 3 vehicles we're looking at today. Third, drone technology and autonomous flight software. Consumer drones led by Chinese manufacturer DJ-1 normalized the idea of multi-rotor electric flight at scale. They proved the battery and motor technology could work. They developed the flight stabilization software. They demonstrated that complex multi-motor aircraft could be flown safely by people with very little training. The eVTOL industry is, in large part, applying the lessons of consumer drone technology to vehicles that carry human beings. In late 2024, the successful completion of over 10,000 test flights across various manufacturers demonstrated the technology's reliability and safety standards. These achievements have attracted significant capital investment, with venture funding in the sector, $12 billion of global venture investment, 10,000 test flights across the industry. The technology is no longer theoretical. Now let's go into the vehicles. Vehicle 1. The Pivotal Helix, $190,000, the one already in customers' hands. Let's start with the vehicle that has the most extraordinary single fact attached to it. It is already delivering to customers. Not in 2026, not soon. Now, Pivotal, the market leader in light electric vertical takeoff and landing aircraft, officially launched online sales for its Helix on January 8, 2024. First customer shipments began June 10, 2024. That is when the world's first commercial eVTOL started delivering to real paying customers, and the company behind it has been building toward this moment for over a decade. Pivotal, formerly known as Opener, introduced the Blackfly Light eVTOL to the market in 2021. The company's distinctive tilt aircraft architecture and scalable platform have been under continuous improvement for more than 12 years. 12 years of iterative development, flying thousands of test flights, refining the design, learning from each generation of the vehicle. After more than a decade of design and development, over 6 years of human flight, and tens of thousands of miles flown, Pivotal has established itself as a true change agent in personal eVTOL aviation. Tens of thousands of miles flown before a single customer took delivery. That is the foundation on which this product sits. What the Helix actually is. Helix is a single-seat electric vertical takeoff and landing aircraft. Unlike helicopters, it has fixed wings, while traditional airplanes need a runway to get airborne. Instead, Helix takes off and lands vertically and runs entirely on electricity. As a result, it falls under the FAA's Part 103 ultralight category, the same regulatory class as a hang glider. That FAA Part 103 classification is the single most important regulatory fact about the Helix, because it determines who can fly it. That distinction matters because it means you do not need a pilot's license to fly it. No pilot's license required. That is extraordinary. And it is not an accident, it is the result of deliberate engineering decisions made throughout the development process to keep the vehicle within the weight and performance parameters that allow Part 103 classification. With an empty weight of 348 pounds, the Helix complies with FAA Part 103 ultralight category in the United States. 348 pounds. That is a remarkably light aircraft for what it does. The engineering discipline required to build a human-carrying electric aircraft at that weight with all the necessary safety systems is genuinely impressive. The design a tilt aircraft. Unlike anything else, unlike a multicopter or a tilt-wing aircraft using complex tilting rotors or wings, Pivotal's novel architecture allows the entire vehicle to rotate while transitioning between vertical flight and efficient, winged forward flight. This means that Pivotal aircraft offer significantly reduced mechanical complexity, lower weight, and far fewer points of potential failure compared to other eVTOL designs. The result is increased reliability and enhanced operator safety. The Helix tilts its entire fuselage and not its rotors, and not its wings when transitioning between vertical and forward flight. The simplicity of that approach is what keeps the weight down and the reliability up. The Helix features a carbon fiber composite fuselage and tandem wing layout, optimized for strength, durability, and safety. 2 fixed wings, one in front of the pilot, one behind. 4 propellers on each wing. The pilot sits in the center section between the 2 wings. This tandem wing layout provides exceptional stability during forward flight. Helix has a top speed of 62 miles per hour and a range of about 20 miles. Depending on the model, it can take from 75 minutes to 4.5 hours to charge. 20 miles of range, 62 miles per hour top speed, 75-minute fast charge on a 240-volt outlet, or 4.5 hours on a standard household socket. The Helix is notably quiet during cruise, rated at around 72 decibels at 150 feet. 72 decibels at 150 feet. That is roughly the noise level of a normal conversation or a busy restaurant, significantly quieter than a helicopter. Quieter than most gasoline-powered recreational vehicles. The safety architecture. At the heart of this single-seat vehicle lies a robust, fault-tolerant design, bolstered by triple modular flight control systems for safety and reliability. Triple modular redundancy in the flight control systems. 3 independent systems making the same decisions simultaneously. If 2 agree and 1 disagrees, the 2 overrule the 1. If 1 fails entirely, 2 backups take over instantly. Distributed electric propulsion means having multiple propellers and multiple electric motors on an aircraft. So if 1 or more propellers or some electric motors fail, the other working propellers can compensate. Multiple propellers, multiple motors, each one capable of partial compensation for any other that fails. Pivotal says across its fleet, Pivotal eVTOLs have completed over 9,000 flights to date. We have a flawless flight record and a flawless safety record. 9,000 flights, 0 safety incidents across the entire fleet. That safety record is the foundation of regulatory confidence in this vehicle, and it is the reason the FAA allows it to be sold and flown without requiring a pilot's license. The training program. Just because no license is required does not mean no training is required. However, Pivotal requires that all Helix pilots must successfully complete comprehensive initial and periodic recurrent flight training to support safe operations in all situations, initial training before delivery, and recurrent training as an ongoing requirement. The company will not hand over an aircraft to someone who hasn't demonstrated their ability to operate it safely. You can order now for July 2024 delivery, and no license is required, although you can't take delivery until you have completed the training. The training is the gateway. Not a government license, but a company-run training program designed specifically for this vehicle and its operational characteristics. The Helix's powerful capabilities are navigated with intuitive joystick controls, guided by a simple user interface. A 270-degree view and quiet operation allow pilots to become immersed in their natural surroundings, fostering a deep connection to the world and the aircraft itself. Joystick controls. Simple user interface. 270-degree visibility. The design intent is clear. This should be accessible to people who are not professional pilots. The packages and pricing. Package 1 offers a white and carbon fiber exterior finish and includes a digital flight panel, canopy, HD, landing camera, charger, vehicle cart, custom marking, comprehensive pilot training, and warranty base price of $190,000. Package 2 offers a gloss white and striped carbon fiber exterior finish and includes the features above, plus a trailer with dual wing cart, 4K camera with landing assist, recording and sharing features, ADS-B air traffic system, 2 chargers, an enhanced warranty base price of $240,000. Package 3 offers an exterior in gloss white carbon fiber with custom accent color and includes the features above, plus a premium flight deck, 3 chargers, beacon aircraft lighting, integrated emergency locator transmitter, 1 additional training slot for a friend or family member, and the option to fully customize the exterior base price of $260,000, $190,000 to $260,000, all U.S. sales only. All requiring completion of training before delivery. The Defense and Emergency Services interest. The Helix is not just attracting recreational buyers. On February 22, 2024, Pivotal announced that it delivered 4 of 8 pre-production Blackfly eVTOL aircraft and 2 flight simulators for evaluation by the United States Air Force Research Laboratory. The AFRL is evaluating the vehicle's military potential for special operations, surveillance, emergency response, and remote supply at much lower cost than helicopters. The evaluation is an 8-month program occurring at the New Braunfels National Airport, Texas, and the National Advanced Air Mobility Center of Excellence at Springfield-Beckley Municipal Airport, Ohio. The U.S. Air Force is evaluating it. 8 months. 2 separate facilities, looking at military applications. When the military is conducting a serious evaluation of a personal flying vehicle, that is not a novelty interest. That is institutional recognition that the technology is real and the potential is significant. In 2024 and 2025 alone, the Helix collected the Silver Stevie Award for Best New Aerospace Product, the New York Product Design Award, and the Gold Edison Award for Futuristic Personal Flight Innovation. 3 major industry awards in 2 years: Silver Stevie, New York Product Design Award, Gold Edison Award. The professional recognition matches the technological achievement. Vehicle 2. The Alef Model A, $299,999, the one that drives and flies. Now, the California-built vehicle accomplished something no other flying vehicle has accomplished before it. It is genuinely both a car and an aircraft, simultaneously. Not a car that can be converted into an aircraft by attaching wings at an airport, not an aircraft that can be towed on a trailer to a landing strip. A vehicle that drives on public roads under its own power, parks in a normal parking space, and takes off vertically from wherever it is standing without any assembly, without any conversion, without any preparation beyond the pilot entering flight mode. The Model A can park in a regular garage, drive on standard roads, and transition to flight when necessary, something no other eVTOL company has achieved. No other eVTOL company in the world has achieved this combination. That is not marketing language. That is the competitive reality of where the personal aviation market stands in 2025. The origin story. CEO of Alef Aeronautics, Jim Duchovny, was inspired to create a flying car after watching Back to the Future. Coincidentally, Alef Aeronautics started developing the car in 2015, the same year that Marty McFly visits in the 1989 film Back to the Future. The movie predicted flying cars by 2015. Duchovny started working on one in 2015. The symmetry is remarkable, and it tells you something about the culture of the company that built this vehicle. Dukovny and co-founders Konstantin Kisely, Pavel Markin, and Oleg Petrov first outlined the design for the Model A in 2015. But there was one huge problem, he says. There was no energy density in the world which can support flying this for more than 10 or 15 minutes. Silicon Valley venture capitalist Tim Draper, an early investor in Tesla and other successful startups, forced Alef to come up with a solution. The problem was energy density. A vehicle that needs to be heavy enough to pass road safety requirements, but light enough to fly and carry enough battery energy to fly for a meaningful distance is an engineering contradiction. Battery technology advances from 2015 to 2019 made the solution viable. And in 2019, a full-scale prototype first flew. Engineers have been building this vehicle since 2015. While they initially thought they could build one in just 6 months, it wasn't until 2019 that a pilot first flew a full-scale prototype. 6 months to build, 4 years actually needed. That honest timeline tells you how difficult the engineering was. The engineering innovation, how the body becomes the wing. This is the genuinely extraordinary engineering at the heart of the Model A. The bottom of the vehicle is completely open plus its structural elements. There is no bottom other than structural elements, and the top is a mesh to protect people from the blades of the 8 rotors, which are inside the box. Also at the center of the box is a passenger compartment, which is articulated so it can rotate with 2 degrees of freedom. The car body itself is the rotor system. 8 internal rotors housed inside the carbon fiber mesh exterior of the vehicle. From the outside, it looks like a car. From underneath, there is no floor. Just the structural elements and the spinning rotors inside. A computer-generated animation showed that the car contains 8 rotating blades underneath its permeable bodywork, which allow it to rise vertically. Once it is a few meters in the air, the whole car rotates sideways so that the blades can propel it forward, while the passenger seat turns so that the passenger remains upright during flight. The entire vehicle body rotates 90 degrees after takeoff. What was the front of the car becomes the top. What was the top of the car becomes the front-facing leading edge. The car transforms into a biplane with the 2 sides of the car body becoming the upper and lower wings. The answer Alef developed was to use the sides of the car as the wings, effectively turning it into a biplane, its body rotating 90 degrees after takeoff to move from upward to forward flight. The whole car becomes a wing, a biplane, a circular wing, and critically, the passenger cabin maintains its orientation throughout. The seat rotates with 2 degrees of freedom inside the rotating body. The person inside stays upright. They feel no disorientation from the body rotation. At this time, the cockpit maintains internal level through the gimbal, ensuring passengers do not feel discomfort or unnatural body tilts in any flight attitude. A gimbal-mounted cabin inside a rotating vehicle body. The engineering required to make that work reliably at aircraft safety standards is extraordinary. The regulatory milestone. Alef announced that its flying car had received a special airworthiness certification from the FAA, the first fully electric vehicle that can both fly and travel on roads to receive U.S. government approval. First FAA-approved flying car that both drives on public roads and flies vertically. That is a historic regulatory milestone not just for Alef, but for the entire personal aviation industry. The FAA is actively working on its policies for electrical vertical takeoff and landing vehicles, as well as governing interactions between eVTOLs and ground infrastructure. Alef's Special Airworthiness Certificate therefore limits the locations and purpose for which Alef is permitted to fly. If you like our content, like and subscribe. Thanks for watching.